Hello. Welcome to a new virtual tour of the European Southern Observatory, or simply ESO, its acronym. My name is Farid Char, and with the producer Felipe Zurita, we are going to be your guides during this trip to ESO Paranal Observatory. So, just to give you a little bit of information about me, I have more than 15 years of experience in outreach and education, astronomy outreach and education. I am one of the guides of the Paranal Observatory since 2010, and I am also working in a astronomy center in the University of Antofagasta, and one of my hobbies is astrophotography. So today I am not alone. I have the producer Felipe. So Felipe, how are you? Good morning. Do you want to introduce
Hi,
yourself?
Richard, and hello, everyone. My name is Felipe Zurita. I have a degree in astronomy, and I love sharing science and astronomy with people in virtual tools and presentially in Observatory La Silla. Today, I will be the producer for this line, and I'm excited to help bring this experience to you. So let's go for it.
Okay, thank you, Felipe. So we are going to start with this experience. Well, I also want to be with you during this virtual visits and bring astronomy directly to your home or wherever you are. So please remember, you can send your questions or comments during all this streaming. Uh, I can imagine you have several questions already. So to do that, you can leave your questions or comments in the comments section of this broadcast uh, in Facebook or YouTube. So Felipe will be ready to receive your questions or comments, and we are going to talk about that and answer your questions during this streaming. Okay, so we are going to start, and the first thing I want to share with you is to understand. We need to understand the place of our visit. Okay, so we are going to start with some information about the European Southern Observatory of ESO. Okay, so in first place, ESO is composed by 16 member states. So the headquarters of ESO are located in Germany, and also Australia has recently joined ESO as a strategic partner. So Chile is the host state and home of all ESO observatories. Let's say that from the 60s, and with those objectives in mind, ESO has chosen one of the best places on the planet for astronomical observations, the Atacama Desert in Chile. So during this period, Chile started several site explorations in order to attract international observatories such as ESO to our country. As a result, Chile offered its territory, and ESO did choose the more suitable areas. Okay, so the mission of ESO is basically to design, build, and operate astronomical observatories. And why? Well, to enable important scientific discoveries and incentivize the promotion and cooperation in the astronomy field. Um, so right now, we are going to show you a picture with the three observation sites of ESO in Chile. So here we have the picture. So here in first place we have the Chagnantor Plateau, the site of the ALMA and APEX radio telescopes. ESO is part of these places for radio astronomy alongside other international partners. In addition, south of the Atacama Desert, at 2,400 meters, we have La Silla Observatory in the Coquimbo region in Chile. So this ESO observatory is the home of several telescopes such as the MTT or the 3.6 meter ESO telescope. And this one is using the HARPS instrument. And the HARPS instrument is an exoplanet hunter. So finally, we have the place of our visit, the Paranal Observatory. This ESO observatory is the home of the Very Large Telescope, or VLT, the most advanced visible light telescope on the planet. Okay? And in the next few years, we will also have the Extremely Large Telescope, or ELT, the biggest visible light telescope on Earth. Also, the CTA will be an array of telescopes focused on capturing gamma rays. Okay, So this is basically the information regarding the facilities. And now we have a better picture to explain this. So now let's travel to the Paranal Observatory. We are going to have this virtual flight over the Atacama Desert in the north of Chile, about 1,100 kilometers north of the capital, Santiago, specifically about 130 kilometers south of Antofagasta, the regional capital, and about 90 kilometers north of Taltal, the closest city. So now we are going toward the mountain top of Cerro Paranal. Um, and Cerro Paranal is located at 2,600 meters above sea level. So this mountain belongs to the coastal range, and despite its altitude, it is located at just 12 kilometers from the coast. And where's the ocean? Well, the Pacific Ocean is located below this cloud cover. Okay, as you can see in the horizon, we have a cloud cover, and the ocean is located below. So why those clouds? If right here the sky is so clear, dry, and lonely? Well, this is because of the influence of the Humboldt current. So this is a cold current near the coast of Chile and Peru, cooling the atmosphere and causing a phenomenon called thermal inversion at about 1,000 meters above sea level, keeping below the cold, humid, and basically bad air for astronomy. So about the layer instead, we have the hot, dry, and less dense air. So this is the, let's say, the good air for astronomy. Okay, so the clouds are blocked by the coastal range, and near Paranal, the mountains are high enough, surpassing 2,000 meters above sea level. So what do you think are other natural barriers we have in this area? Well, about 200 kilometers to the east, we have the Cordillera de los Andes, okay, or the Andes Mountains. So they are basically very high mountains, more than 6,000 meters above sea level. So this is another natural barrier blocking clouds from Argentina and Bolivia. So the main result is this landscape, a place with an average of more than 300 clear nights per year, with a very clear and transparent atmosphere, making it ideal for observing the night sky. Also, here we are far away from artificial light sources because of human activity. I mean, light pollution. Okay, so this is one of the best places on Earth for astronomical observations. So right here we have another view of Paranal, as you can see in this simulation, in this video, to let you know an even closer look to Paranal. Okay, so as you can see, this is not an ordinary mountain, and now we can see the different telescopes and structures in the mountain top. We are at the summit of Cerro Paranal. Do you know what Paranal means? Well, in the Quechua language, Paranal means whirlwind, possibly because of some whirlwinds we forming in the desert. However, as I told you already, the atmosphere here is extremely quiet. So this observatory is basically a true oasis. And you will see how in one of the driest deserts on Earth, we have a lot of life, and of course we have also a lot of science. Okay, so right now we are going to visit the summit of Paranal. So we are going to change the view, and now we have the mountain top of Cerro Paranal. So in front of us we have the Very Large Telescope, or VLT, its acronym. Okay, so if you see the amount of buildings, okay, so we have four giant domes, okay, and other small and rounded ones like this one, okay. It is clear that the very large telescope is, in fact, is not only one, but a very special array of telescopes. So all this facility is the most advanced optical observatory on Earth. So let's take a closer look. So here you can find the four unit telescopes, okay, or UTs, each one with a primary mirror of 8.2 meters of diameter. Okay, the giant one, the giant ones in your screens. And the other small ones are the auxiliary telescopes or ATs. So here we have one, we have two, we have three, and we have four. Okay, so we have four auxiliary telescopes and main unit telescopes. So basically, each AT, each auxiliary telescope, has a primary mirror of 1.8 meters of diameter. So each UT has a name in a Mapudungun language. This is the language of the Mapuche culture. These they are natives from central southern part of Chile. So here, for example, we have Tu, CEST. Okay, here we have Cuyen, and Cuyen means moon. Melipal means 4 stars, but this is a reference to the Southern Cross constellation. And here we have Jepun, and this is a word associated related to Venus, okay? Because this is a concept referred to the evening star, okay? So, as I told you before, we have other telescopes. We have these closer ones, the auxiliary telescopes, and the important information about this is that they are close, they are mobile, and they can be moved using a rail system, okay? Up to 30 different positions. Okay, so they were specifically designed to work all together. Okay, I mean the four big telescopes here they can work all together, but but the small ones are specifically designed to work all together all the time. So the purpose of this is to work as a simulation of simulation of this. So please, Felipe, do we have a simulation to show? Okay, here we have the simulation. So this is what happens. This technology to combine the light from more than two telescopes is called interferometry. Okay, this is the name of the technique to combine light from several telescopes. So we are able to observe much more specific details if you compare this with the individual telescopes. So thanks to interferometry, we can simulate a giant mirror to distinguish details up to 16 times fainter than a single telescope. Okay, so why don't we make small telescopes and combine them to create a huge telescope? Well, interferometry also has limits, and some information is lost during its travel. However, it is still an excellent solution to observe objects too difficult to observe with our current technology. Okay, so right now we will come back to the tour screen. Okay, so now we have the platform again. This is the platform of the telescopes again. And now we are going to enter to one of the telescopes. We are going to enter to this one. We are going to visit Melipal. Okay, don't worry about this. All telescopes are exactly the same, so it's not important to enter to the four telescopes. So we are going to enter Melipal to take a look at the telescope inside. Okay, so here we go. And here we have the telescope. Can you see? So what can you see? Um, well, this is a giant telescope. Okay. Um, we are on the last floor of the telescope at the same height of the main mirror in front of us. Okay. So the mirror has 22 tones, and I will do some kind of close up. So you will you will see the mirror there, and you can see how the mirror looks like. Okay, so we are at the last floor of the telescope at the same height of the main mirror. Okay, and the mirror, as I told you before, has 22 tons with 8.2 meters of diameter and only 17 centimeters thick. Okay, and the mirror was created from a ceramic and flexible material called cerudur. So how can we point to this telescope to the sky without breaking it? Well, we will see this telescope from another angle, so we are going to explain that. Okay, so here we have a general view of the telescope and the surroundings. And now I will show you the telescope from another perspective. So we are going there. Okay, so now we are in something like the uh, main platform of the telescope, and you can see the telescope is there. Okay, so now something important from here. The mirror is mounted over this white structure. Can you see? This is a cell supporting all systems assisting the mirror, including something called active optics. And here you can see some little gray boxes. I will show you. Here, here, we have some gray boxes. Can you see? So the gray boxes are actually, the technical name is actuators. Okay, so the actuators are a kind of piston, and we have 150 in total, controlled by a computer. So they are acting on the mirror during the observations in order to keep the optimal shape of the concave mirror. Okay, the concave shape of the mirror. Otherwise, it could suffer deformations just because of gravity. Those deformations, imperceptible in a first view, could be critical in the result of the observations. Okay, so that's why we are using active optics with the actuators. Okay, how is this working together? How the telescope is working at night? We are going to come back to the first view, to this perspective, and now we are going to explain a little bit how the telescope works with a short animation. So, Felipe, do we have the animation? Okay, thank you. So this is what happens. Basically, we have to open the dome at night. This is, of course, exaggerated. Okay? And you will see that the telescope will have to receive light. So the first step is that the primary mirror will receive light. The light will be concentrated and reflected to the secondary mirror there, up there. And then this light will be reflected again to a tertiary mirror, a flat mirror in the middle. And from there, the light will be reflected again to one of the three possible instruments. And here you can see something like a red box, blue box, and green box. These are representing the instruments. So we have three possible instruments. Um, the instruments are all different. So basically, it's very interesting to have this system because we have more flexibility to use a different instrument for different kinds of observations. Okay, so this is what happens when the telescope is working at night, and during the day. Okay, during the day, the work is not for astronomers, but it's more for engineers. So you can see here, for example, we have some engineers working because during the day we need to do some maintenance, we need to fix problems, we need to basically prepare the telescope for the next observation night. So that's why we have people here. They need to fix any issue during the day. And this, for example, is one of the instruments. Can you see? So it's a huge instrument. And as I told you before, this is only one of the possibilities, okay? Because we have another instrument in the opposite side, okay? And we have another instrument there in the base. So basically, this is what happens here. This is the general explanation about the telescope. As I told you already, well, this is Melipal, but we don't need to visit all the telescopes because all the other telescopes are exactly the same structure. Okay, the only difference is that each telescope has three different instruments. Okay, so we have basically three instruments per telescope. Okay, so that's all the explanation here. So now we are going to change location. We are going to finish this visit to the telescope, and now we are going to come back to the main platform, the
We
VLT
have
platform.
a
Yes.
question, interesting question, and this is how the telescope use the principle of physics to detect invisible wavelengths like the infrared or radio waves. The principal principle to see the infrared and radio waves is a spectrum, like spectrum. This is the principal physics for see the sky, the infrared, radio, gamma rays. In particular, what wavelength can see the BLT for you?
Excuse me, say again, Felipe.
What what is the principal wavelengths can see the BLT?
Oh, well, because Paranal is an optical telescope, Paranal can observe visible light, of course, and can observe a little bit of ultraviolet and the near infrared. So, well, if you want to observe radio, you need a radio telescope. So, in this case, we are using ALMA, for example, because ALMA is using antennas to catch radio waves. But in the case of Paranal specifically, we are able to observe those specific wavelengths.
So that is the question. And remember, you can leave your questions whatever you want about astronomy, the virtual tour. You can leave your comments or greetings wherever you're from Amsterdam. Hello, hello, Charles. And you can leave greetings and question you want. So, what is the next point for you?
Okay, Felipe, thank you. Yeah, please don't forget to send your questions or comments, and Felipe will be uh, talking about that in the next stop. So yeah, the next activity is basically to visit the control room because we have the telescopes here, but the telescopes, in order to operate the telescopes, the astronomers and the scientists they don't need to be there. They don't need to be inside of the telescopes. They are in another facility. So basically, we are going to rotate the view, and you will see that we have a building here. Let's say in a different level, not in the same level of the telescopes, and I will show you this building from the other side. So it's basically this, you see? So this building is the control building. And here we have different offices for some engineers, we have some laboratories, and we have the actual control room in the last floor. Okay, so now we are going to do a visit. We are going to visit this control room. So you will take a look at how the astronomers are working at night. So here we are, and now we are in the control room of Paranal. So as you can see, this place is basically eh, it looks like an office. It looks like a big office. Okay, and you can see that we have different workstations here. Okay, so each workstation, as you can see, we have several computers, screens. Okay, and each workstation is dedicated to one specific telescope. So this workstation, for example, is dedicated to Melipal. So only operations with Melipal are from here. Okay. Opposite, we have this workstation, and this one belongs to UT4 Jepun. So all operations with Jepun are from here. Okay, so you can see again we have several computers. Okay, we have some people working there, but basically we have a different space for this telescope. Now, if we continue working through this virtual corridor, we are going to take a look at the other stations. So we have here the workstation for UT1 and 2, okay? So again, we have some screens, we have some computers, we have some people working, and in the other side, we have the last station for the Kujen telescope, okay? So as you can see, each telescope has a dedicated space. We are going to take a closer look to this workstation. So you can see here the computers. We have different software to do the remote control of the telescope. So basically, in each workstation, we have a telescope operator and we have an astronomer. So basically, all the telescopes, instruments, and systems explained before are controlled from here. Okay, so as I told you already, during the day, the engineers, technicians, and scientists are working to prepare the telescopes for the next observation night. So each night we have a telescope operator and an astronomer per telescope. Okay, so in this case, well, this person is a telescope operator, and let's suppose this person is the astronomer. Okay, so the telescope operator is the person in charge of the technical details and the movement of the telescope. So basically, it's like the pilot of the machine. Okay, uh, the ESO astronomer is in charge of to direct the scientific observations and will decide the next steps. So he's like the co-pilot. Okay, so the observations from here are performed by experts from ESO for scientists from all the planet. Okay, so here is when the science is performed. Okay. Okay, so again, one more time, don't forget to send your questions or comments, okay? Because we will have some opportunities to read your questions or comments, and Felipe will be ready to receive them. Felipe, do we have any other question or comment, or can we continue?
Uh,
You can tell me.
we have a punctual question about the physics of the gravitational lensing play in the enhancing or the most more capability of the telescope to observe distant galaxies and phenomena in the universe. Irelia asked them, that's right, gravitational lensing is a phenomenon to allow astronomers to see distant objects. It's a help to the gravity, the mass gravity of the distant galaxies to see other distant, more far distant galaxies, and occur with massive objects like clusters, warps, and it's similar to how a lens of can I see edge glaze, the glaze of the eyes, bend light. So the result is you can see the other far galaxies away. That is a bring help to the telescope to enhancing the capabilities. This is a particular physics and a specific question about the gravitational lensing, but that is interesting. This is much more professional question, but thanks to answer if you need to ask about all this. And BLT is capable to see the lensing of the distant galaxies too, right? I
Excuse
think so.
me, Felipe? Say again,
I
please.
think the BLT can see the lensing of the distant galaxies, the gravitational lensing.
Yeah. In some cases, you can see this kind of gravitational lensing when you have well, a very long exposure, probably. But yeah, this is a very fascinating phenomenon, and well, probably more famous pictures uh, showing gravitational lensing are obtained by the James Webb Telescope. But yeah, I think we have some pictures taken from Paranal showing the same phenomenon. So yeah, this is something very fascinating. And for example, with the next ELT, will be possible to study in even more with even more detail this kind of situations because we are talking about very distant objects, and we can understand better the physics behind the gravitational lensing. Okay, Felipe, I think we are ready to continue. If
That's
we
right.
don't,
I have a video about the
okay,
ESO top 10 discover about the principal discovering of the of the universe. So you can answer the if if you have loved one of the top 10 is a gravitational lensing. So let's go.
okay, thank you.
Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in history, elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at La Silla was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang Theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone.
Okay, so this was the top 10. Of course, it was very, very interesting. But we have something else. We have something like a bonus track, and this was about another important discovery from a few years ago, but still very, very relevant. So, Felipe, do we have this additional sequence, please?
Let me show you here.
Uh-huh. Okay, thank you. So, well, we have now another important discovery, or let's say observation. Basically, a team of astronomers was able to capture the first image of a black hole. So, with the Event Horizon Telescope, or EHT, its acronym, well, this is an array of 8 ground-based telescopes distributed on the planet, working as an international collaboration, and it was able to achieve the first direct evidence, okay, um, of a supermassive black hole. So the picture reveals the black hole in the center of Messier 87, and this is a massive galaxy in the close galaxy cluster in the Virgo constellation. This object is located at 55 million light years from Earth, and its mass is about 6,500 million times the mass of our Sun. Okay, so that's it. This is regarding the most important discoveries or milestones. And now I think we are in conditions to move on, and we are going to change the location. We are going to come back to the VLT platform. But now we are going to show you something very special. We are going to take a look at Paranal at night. Okay, so here we are in the Paranal Observatory at night, and we have the opportunity, thanks to this virtual experience, to take a look at what happens during the night in this observatory. And you can see that in this case, in this picture, we have the sky. The sky is almost completely dark, with the last traces of light from the twilight. The moon is below the horizon, and the sky is full of stars. So it's beautiful. So here we can see the first important thing to show you, a very popular constellation. Okay, so we are going to do a close up. So this constellation is Orion. Okay, in the mythology, Orion represents a hunter. So in this case, regarding Orion's constellation, you can recognize this constellation because of those three stars, because they are somewhat aligned, right? Um, and these stars represents Orion's belt. And inside of Orion, here, we can see another interesting object. This is the Great Orion's Nebula. Okay, so now we are going to change the position and move to the brightest star in the night sky. So we are going to move there, and we are going to take a look at this star. This star is called Sirius. Okay, Sirius belongs to the Canis Major constellation, and this constellation represents Orion's hunting dog. So basically, the constellation related to this star is connected in the mythology to Orion. So now we are going to change the position a little bit down. So I will show you that just next to Antu, next to the telescope right here, we have another important object. We can see the Pleiades. This is an open star cluster located in the Taurus constellation. So the majority of those objects are visually close to a specific area, an area that is very populated with stars. So you can see here this area. You see, here is possible to see that we have a lot more stars if you compare with this area or this area. Okay, so actually this band of stars is one of the arms of the Milky Way. Um, and the Milky Way, of course, is our galaxy. And our sun is only one among hundreds of millions of stars. So during the winter in the southern hemisphere, we can see the center of the Milky Way. And the center of the Milky Way is another area full of stars. between Scorpius and Sagittarius. Okay, so Scorpius and Sagittarius are other constellations, and you can see all this area from this hemisphere, from the southern hemisphere. Okay, so now we are going to move to another sector in the sky. We are going to move this way to find two spots in the night sky. So you can see here, okay, we have two spots there. Okay, so basically those spots right there are the Magellanic Clouds. Okay, up there, here we have the large Magellanic Cloud, and down there we have the small Magellanic Cloud. They are not actually clouds, of course. They are galaxies with an irregular shape, but visible to the naked eye in a clear night like this one. So the name refers to the records from Ferdinand Magellan during its circumnavigation of the planet in the 16th century. So during this time, the people were unaware about what a galaxy is. Okay, so that's why today we know these galaxies by the name of Magellanic Clouds. So another important area here I will show you is located just there. And this area is interesting because we can see um, the Southern Cross, this one, the smallest constellation in the sky. So as you can see here, the cross is a little bit tilted, right? This is an easy constellation to find in the sky. It's only visible in this hemisphere, the southern hemisphere, and it's a good guide to find the south celestial pole. The south celestial pole is basically a projection of the Earth's south pole. So during the night, the stars appear to revolve around this point. So to find this point, we are going to do this. We have to extend, well, in our imagination, the longer stick of the Southern Cross right here. So the longer stick must be projected or extended about 4 times and a half. So we have the longer stick here, and we have 1, 2, 3, and 4.5, and more or less like here, we have the south celestial pole. So this zone also, this point also indicates the south cardinal point. So for example, if we take a look at this horizon, the location of the south celestial pole, if you look at the horizon, just there, okay, we have here the south cardinal point, okay, in the horizon. Okay, so this is the conclusion of our visit to Cerro Paranal. Now we are coming back to the platform in the daytime. And now we are going to visit another place. We need to go down. We need to go to the base camp at 2,400 meters altitude. Okay, remember in the BLT platform we have 2,600, but we need to go to the base camp located at 2,400. Okay, so this is the base camp, and we need to visit a very specific place here. This is something like a mini city because we have all the workers. For example, the people working under a contract. Under the category of contractors. Sorry, they have some rooms here. Okay, but we also have some things like a warehouse, a workshop. The mirror maintenance building, some offices for informatics, etc. Okay, but here we have to visit a very specific place located there. This is the residence. Okay, so the residence is a separated facility here. In the residence we have the ESO staff. Okay, so basically the people with a contract with ESO. So the residence, as you can see, we need to access this residence using this ramp. So this place looks like underground, but it's actually just taking advantage of the shape of the land, because in the other side, in the opposite side, we have an actual wall with windows. Okay, but here we have a ramp, and from here I will show you what happens, what we have inside, because this is a very nice place, and of course it's available for the workers, because all the people in Paranal are working by shifts. so they have some time to enjoy, as you can see, this beautiful place. So right now we're in the residence, okay? As I told you before, the ESO staff can stay and rest here, and the residence is the home of the ESO staff during their work in the desert. So here the workers can enjoy a more humid air. They have a swimming pool, they have green areas, and also we have, in general, more rest compared to the desert and the intense sunlight from the outside. So here you can see also we have some places like the restaurant over there. Uh, all workers can go there for eating lunch, dinner, you know. This area, in this area we have the lobby. In this area we have the reception. So this is mostly, it looks like a hotel, but it's only for the staff. Okay, and if you cross this area, this entrance is going to all the rooms, and we have 108 rooms in total in this residence. Okay, so this is basically what happens here. This is the Paranal residence, and we are approaching to the end of this virtual experience. So I don't know, Felipe, if we have some other questions or comments so far.
We are two questions. I read the first important, and there master students who are working on their thesis in Paranal. Is there this possibility to do the master in here in Paranal?
Well, we have some people doing practice, some practice in not specifically in astronomy, also in engineering. Um, but basically, this I think this depends more of if you have a kind of project, okay, and if you apply with some kind of project, if you have some uh, things like an internship or something like that. I think maybe. I think that the right answer can be found in the ESO recruitment portal because they are announcing sometimes some opportunities for students. As far as I know, it's mostly for PhD students, but uh, this person can check there in the ESO recruitment portal. But as far as I know, they have internships and they have some opportunities for professional practice. But they are announcing this kind of opportunities time to time. Okay? But basically, that's the only information I can provide about that.
And the other one is more to things about why astronomy is less focused on studying stars themselves and more interest to investigate more complex phenomena. I hear that in the past, why astronomers more investigate the extragalactic place and less in the stars. But I don't think this is true because I have astronomers in investigate the protostars. You can find astronomer investigate the still investigate the star formations. You can find a lots of people investigate the little hits balls in the in the sky. But in the other parts, you can find galaxy, intergalactic, galactic astronomers investigate different parts. It's not less focused in studying stars. It's a difference. How I say part of the astronomy. You've already studied in stars or galaxies.
It, excuse me, say again, Felipe, please.
You focus on studying stars or galaxy in astronomy.
Well, if the question is related to what happens in Paranal specifically, uh,
In Paranal specifically, study buds and stars and galaxy too.
well, yeah, just to answer, well, because the question is very generic. In Paranal specifically, the main criteria to say, okay, we are going to observe this or this, is that in your proposal, because you need to submit a proposal to Observing Paranal, you need to demonstrate that you can satisfy a scientific criteria. And of course, you need to provide some kind of evidence or justification to use an 8.2 meter mirror telescope, okay? Because not all projects actually require 8.2 meter telescope. Um, Now, if the question is related to complex phenomena in the universe, it's because right now we have enough information uh, related to stars. We have a lot of catalogs. We have a lot of general information about the stars, about the evolution, about uh, um, the different stages of the evolution of a star. So right now we are trying to understand better other kind of phenomena um, with the new technology. Because, for example, 20 years ago, you have no idea that maybe an exoplanet can orbit another star. Okay, for example, or 30 years ago, you have no idea about that. But once we discovered the first exoplanet, we began to do more efforts to study exoplanets and to build instruments to study exoplanets and so on. So you are trying to be more specific in your quest for knowledge, okay? So now, for example, other specific questions that we have about the universe are, for example, if an exoplanet, for example, can sustain life. So regarding this, for example, I can tell you that with the ELT, with the next observatory by ESO, we are going to observe something so specific like, for example, detecting the atmospheric composition of an exoplanet. And with this information, maybe we can understand better what happens in the exoplanet, of course, but also we can try to determine if maybe the planet could sustain life. Because, the atmosphere, the chemical composition of the atmosphere of another planet is, of course, important to to estimate this. Okay, at this moment we are able to study exoplanets, but at a very basic level, because we don't have all the technology to understand what happens there, and of course we don't have a spaceship to travel there. So yeah, maybe it looks like the stars right now. We have a lot of knowledge about the stars, and now we are trying
Mm.
to focus on more specific things, specific
That's
things
right.
about the stars, specific things about galaxies, other planets, etc.
So thank you for your questions. Today we have more complex questions, but thanks
Yeah.
for that. And that is the last part of the visit tour.
Yes. Yes. So yeah, what we are approaching to the end of this virtual experience. So well, I hope you enjoy, of course, and because well, I can tell you that we have visits, public visits to Paranal and La Silla. For example, right now on Saturdays we have visits, public visits. For Paranal specifically, we have public visits on the Saturdays at 10 a.m. and 2 p.m. And the visit takes approximately 1 hour, 2 hours and a half. But you need to arrive to the observatory with your own car or vehicle. Um, Paranal is located 1 hour and 30 minutes from Antofagasta, but you need to do a reservation in advance. So I can suggest maybe 2 weeks, 3 weeks in advance, because we have a lot of people trying to visit Paranal, but we have limited spots. Okay, so we have about 80 spots per tour. So, of course, will be a very nice experience, because this is a virtual experience to show you everything about the observatory. But of course, you can also try to visit Paranal and also La Silla.
Mhm.
Okay, so I think we are reaching the end of this experience. So thank you very much for your presence, your virtual presence. We remind you that all this visit information and pictures are available on the ESO website. And we invite you to keep exploring and investigating about astronomy from the ESO website. Okay,
That's
Felipe.
right.
So that's all from
Th-
my side.
So see the next week in another virtual tour. So see you soon. Bye.
See you. Bye bye.